In this video, we're gonna talk about the rational function in sine and cosine. This one will be considered as application of the partial fraction technique. We're gonna be able to integrate the function that is in the form of rational function of sine and cosine, like in example 1, 2, and 3. I'm gonna do 3 examples. It's gonna be that hard to do, but it's gonna be kind of tricky a little bit. So the thing that we're gonna use is gonna be we're gonna let z equal to 10x over 2. So the key thing will be if I were you, I gonna memorize only we're gonna let z equal to 10x over 2. It's gonna be half angle. So it's gonna be the technique that I have a nickname for. It's gonna call half angle. So you have z equal to 10x over 2 and you're gonna solve for x. So you solve for x, you're gonna get x over 2 equal to arctan z. Okay, so you have x over 2 equal to arctan z. And you're gonna solve for x, so you would get x equal to 2 arctan z. Okay, so you get x equal to 2 arctan z. So this is you're gonna use basically, and you're gonna use this one. So basically just memorize two things, z equal to 10x over 2 and x equal to 2 arctan z. And then you're gonna dip both sides. So you're gonna dip x is gonna be dx and you're gonna dip arctan is gonna be 2 over 1 plus z squared dz. And you're gonna use the formula about the half angle in terms of tan of sine x and cosine x. These two guys are trick identity that you have learned in high school that you may not be able to memorize this one. But if you don't want to memorize this one, you may just read this one. So it's going to be sine x equal to 2z, 1 plus z square, and cos x turned out to be 1 minus z square over 1 plus z square. They come from the identity 2 tan x over 2 over 1 plus tan square x over 2. Okay, so this one will be sine x and another guy will be cosine x. Okay, so this one will be fine thing totally. Okay, in my opinion, this one is fine thing totally. The first one is z equal to 10x over 2, x equal to 2 arctan z, and you have the x equal to 2 over 1 plus z square. Okay, I'm gonna show you how I memorize this thing. Okay, so the thing that I memorize turned out to be I'm gonna let z equal to 10x over 2. Okay, so you solve for x, so you get x equal to 2 arctan z. Okay, so this is gonna be the thing that you get first. And then what? And then you're gonna compute dx. So it's gonna be 2 1 over 1 plus z square dz. So you just dip both sides basically as I told you. Okay. And then what? And then you're gonna have sine x equal to 2z over 1 plus z square by trigonometric identity, and cos x turn out to be what? Turn out to be 1 minus z square over 1 plus z square. And so you're gonna substitute them. Okay, so you have sine x given by this guy, cos x given by this guy. Okay, so for this one, so you have sine x, which is the yellow guy, and cos x, which is the pink guy. So you would get integral. Okay, so you would get integral 1 over, okay, and you have cos x, so it's going to be 1 minus z square over 1 plus z square. and sine x will be 2z over 1 plus z square, and you're gonna plus 1, and you see that you have dx equal to 2 over 1 plus z square dz. So it will be 2 over 1 plus z square dz. So this one will be the green one. And so you are gonna highlight the color first. So you get this one is cos, this one is sine, okay, and you copy everything down according to the color. So you see it's look messy. However, if you multiply everything by 1 plus z square, so you see that the algebra that you can perform here is going to be you multiply to this term and you multiply to this term, you would get something kind of nice. So let me multiply that and show you. So it's going to be 1 over, okay, so and it's going to be 1 over. So for this guy, you have 1 minus z square, and you have negative 2z, okay, and you're gonna have the green guy multiply 1 plus z squared, so it's gonna be plus 1 plus z squared. Let me highlight to see whether you get the color. So this one is the yellow, this one is the pink, and this one is the green one multiply with 1. Okay, so you see that the green guy multiply with 1, and on top, instead of 1, you would get number 2. Okay, so and this come from the green color as well, and you have this. So this is what you having, and then you simplify this one. So the bottom one, you would get 1 minus z square minus 2z plus 1 plus z square, and you see that this z square and z square cancel each other because they have opposite side. So you get 2. Okay, so this one will turn out to be kind of nice. So it's gonna integrate, and you have 2 on top, and you have 2 minus 2z dz, and this one will be so it's gonna be 2 minus 2z. So this guy will be integrate 2 over 2 1 minus z dz. Okay, and you have 2 and 2 get rid of, so you would have finally integrate 1 over 1 minus z dz. Okay, so you have integrate of 1 over 1 minus z dz. And finally, you gonna be able to integrate this one, right? So you integrate this one, you have a equal to negative 1, and you integrate this one, is gonna turn out to be log absolute 1 minus z over negative 1. Okay, so this is the formula that I recall you before, that when you integrate 1 over a x plus b, it's gonna be, this one is dx, it's gonna be log absolute ax plus b over a. Okay, so it's gonna turn out to be this guy, and u plus c. Okay, so this one will be just log absolute 1 minus z over negative 1 plus c, and finally you're gonna plug in z, so it's gonna be negative log absolute 1 minus and z equal to 10x over 2. okay, and u plus c. So this is how we have your final answer. Your set turned out to be 10x over 2. Okay, so you plug everything in nicely. Let me zoom in to see the whole question a little bit. So you see that this is how we use the uh, half angle substitution. I would say it's half angle substitution. So you have z equal to 10x over 2 and you'll be able to convert the rational function in sine and cosine in order to integrate. And you see that the trick that we have here and the final integral that you have here turn out to be partial fraction. Okay, so the next one you have 1 over 10x minus sine x dx. So you're going to begin with the same 5 items that you have here. So let me just crop them, okay, to use it on the next page. So this one, I just copy this guy and I'm gonna use this same guy on this page also, okay. So I'm gonna use the same color as you can see. So you're gonna use the green guy for dx and you have sine x, which is the yellow guy. I need the yellow color. So you need the yellow, okay. And you're gonna find 10x. Let's find 10x. So in this case, my 10x turned out to be sine x over cosine x. When you have 10x equal to sine x over cosine x, for this one, you see this quotient and the thing that you're gonna get rid of will be the bottoms. So in this case, you would left with 2z over 1 plus z square. So this one will be 2z over 1 plus z square. Okay, so you have 10x equal to 2z over 1 plus z square. So you're gonna integrate. Okay, so it's gonna be 1 over 2z over 1 plus z square. Okay, minus sine x. So you're gonna minus sine x. What is sine x? It's gonna be 2z. I make a mistake again. So this one is going to be 1 minus, not 1 plus. So this one will be 2z, 1 minus z square. Okay, so this one you get rid of these two guys. The thing that you have is left is going to be minus sine. So you have 2z over 1 plus z square. Okay, and this one will be minus sine. Be careful a little bit on this calculation. Okay, so this one will be just like that, and this one will be the yellow guy, right? And you have dx, and dx is the green one, so it's gonna be 2 over 1 plus z square dz. Okay, so for this one is the green one. Yeah. Okay, and you have integral, okay, and you sum this one up, so you get this one. So let me like ease the calculation a little bit. So I just gonna sum this one up, so it's gonna be 2z, and you gonna let me use the like a long line and with color, so I'm not going to confuse you. So it's going to be 1 plus z square, and it's going to turn out to be minus 2z and multiply with 1 minus z square. Okay, and on the bottom you would have the product. Okay, so you get 1 minus z square, 1 plus z square. Okay, and you have the green one copy down, so it's going to be 2 over 1 plus z square dz. Okay, and you see that we be able to get rid of 1 plus z square. Okay, and you be able to see that we be able to get rid of this 2. Okay, so it's gonna kind of simple, and you're gonna be able to also flip this one to the top. So you would get 1 minus z square on top. Okay, and you're gonna get the thing that you have on the bottom. Okay, so the thing that you have sitting on the bottom, so you get z plus z cube minus z plus z cube. Okay, so it's gonna be z plus z cube minus z plus z cube. So this one will be getting rid of. So it's gonna be 2z cube. Okay, so this one will be dz, and it's turned out to be integrate 1 minus z square over 2z cube dz. Okay, so it's gonna be 1/2 integrate 1 over z cube, and you have z square over z cube dz. Okay, so this guy will be 1/2 integrate z to the negative 3, and for this one and this one you get 1 over z, so it's going to be 1 over z dz, and you integrate this one, so you get 1/2, and integrate z to the negative 3, so you get negative z to the negative 2 over negative 2 minus. Okay, so it's going to be minus log absolute z. Okay, and you plus c. Okay, and you're gonna obtain the final answer. So let me write the final answer down. Okay, so you're gonna put z equal to 10x over 2 back into the final answer. Okay, so it's turned out to be 1/2. Okay, and you get 1 over 2z. Okay, so it's going to be 1 over 2z square. This one. Okay, so for this one, I have negative. I don't have negative here because I'm gonna have only one negative. Sorry, I have negative on the bottom already, and I gonna change. Okay, so it's gonna be 1 over 2, okay, 10x over 2 minus, you have log absolute 10x over 2, okay, and you're gonna plus c for final answer. Okay, so this one will give you this integral in terms of x, and you're gonna use the technique that you are having this one. Okay, so this one will be the thing that I call the rational function in sine and cosine, and you'll be able to obtain the final answer in this form. Okay, let me also highlight. I'm not quite sure that I'll be able to highlight. Okay, so this one are set that you are plugging in. Finally, you're gonna like to try to integrate cosec. For integrate cosec, we already know. Okay, so we know. Let's say we know. Okay, integrate cosec x in terms of log absolute cosec x minus cot x. Okay, so you already know this one, but we not gonna do this one. okay, here. So in this case, it's gonna turn out to be another formula for integrating cosec x, okay, by using the technique that we just learned. Okay, so let's copy file guy. Okay, so I'm gonna paste this guy. Okay, so we still need to use something like this, like the same thing. So for cosec x, what is cosec? So this guy turned out to be integrate 1 over sine x dx. And you see that your sine x is the yellow guy and your dx turned out to be the green guy. So you turn out to write, okay, sine x is going to be 2z over 1 plus z square, and your dx turned out to be 2 over 1 plus z square dz. So this guy is the green one, and this guy is the yellow one, okay? And you multiply this one, so you get this guy and this guy. So you see that it's turned out to be very simple. So it's going to be 2 cancel with 2, and it's turned out to be integrate 1 over z dz. Okay, so if you use this technique, it's turned out to be very simple integral, and it's gonna be what? It's gonna be log, okay, absolute. Okay, so it's gonna be log absolute 10 x over 2. Okay, so it's gonna be log absolute 10, log absolute z plus c first. And you're gonna plug everything back in, so it's gonna be 10x over 2 plus c. Okay, and this guy is the blue one, and this one is your stat. Okay, so you see that before we used to find this integrate cosec in a harder way. However, this one, the hard thing turned out to be on this identity instead. So at the end, it turned out to give you something very simple to do. Okay, so this one will be just integrate cosec. Okay, so that's it for these 3 examples on the rational function of sine and cosine. I'm gonna have another application for partial fraction in the next video. That is gonna be our final lecture. Okay, so I'm gonna first stop here, and we're gonna continue the next application about the substitution for the n root of ax plus b next.